For 76 years, Pluto held a specific, comfortable place in the popular imagination. The ninth planet, the small, distant, icy world at the edge of the solar system that generations of schoolchildren memorized alongside Mercury, Venus, and Earth. Discovered in 1930 by astronomer Clyde Tombaugh, working from careful, painstaking comparisons of photographic plates taken weeks apart, Pluto was hailed at the time as a major discovery, a new planet found through old-fashioned, meticulous observation rather than any grand theoretical prediction. Then, in 2006, the International Astronomical Union voted on a new, formal definition of what qualifies as a planet, and Pluto did not meet it. Overnight, in the public imagination at least, Pluto was demoted, becoming instead the best-known member of an entirely new category: dwarf planets. The decision remains genuinely controversial among astronomers and the public alike, even years later. But almost exactly as the debate was peaking, a spacecraft was already years into a journey specifically to visit Pluto directly for the first time in history, and what it found, when it finally arrived, turned out to be far stranger and more active than almost anyone had expected from a small, supposedly frozen, dead world at the edge of the solar system. The 2006 reclassification did not happen on a whim. It followed the discovery, in the years just before, of several other icy bodies in the outer solar system comparable in size to Pluto, including one later named Eris that appeared, by some early measurements, to be slightly more massive than Pluto itself. Faced with a growing list of Pluto-sized icy objects in the outer solar system, astronomers recognized a genuine choice. Either declare all of these newly found objects planets too, potentially adding dozens of new planets to the solar system as more were discovered, or establish clearer, more rigorous criteria for what the word planet actually means. The International Astronomical Union's new definition required a planet to orbit the Sun, be large enough for its own gravity to pull it into a round shape, and, the criterion that specifically excluded Pluto, have gravitationally cleared its orbital neighborhood of other debris. Pluto orbits within a crowded region called the Kuiper Belt, sharing its orbital neighborhood with countless other icy bodies, unlike the 8 recognized planets, which have each gravitationally dominated and cleared their own orbital paths over billions of years. Many astronomers, including some members of the mission team already en route to study Pluto directly, publicly disagreed with the decision, and the debate over the right definition of a planet continues among scientists today. Regardless of the label, Pluto itself did not change, and a spacecraft was already on its way to show the world exactly what it looked like up close, for the very first time in human history. NASA's New Horizons spacecraft launched in January 2006, just months before Pluto's reclassification, beginning a journey of more than 9 years and roughly 3 billion miles to reach a world so distant that even the best images from Earth-based telescopes showed it as little more than a blurry, indistinct dot. Launched faster than any spacecraft before it, New Horizons still needed a gravity-assist flyby of Jupiter along the way, using the giant planet's gravity to add speed and shorten the remaining journey. Even so, by the time the spacecraft finally approached Pluto in July 2015, radio signals between it and Earth took more than 4 hours to travel one way, meaning every command had to be planned meticulously in advance, since no real-time piloting was remotely possible at that distance. The flyby itself lasted mere hours, with New Horizons unable to slow down or enter orbit. It simply raced past Pluto and its moons at high speed, gathering as much data as possible in that brief window before continuing onward into deeper space. Every image and instrument reading had to be captured during that narrow flyby, then transmitted slowly back to Earth over the following months, given the enormous distance involved. What those images revealed, when they finally arrived, surprised nearly everyone who had expected a simple, geologically dead ball of ancient ice. The first clear images of Pluto's surface revealed something nobody had confidently predicted: a startlingly varied, geologically active-looking landscape, including a massive, bright, heart-shaped region of frozen nitrogen that quickly became the mission's most iconic image. That heart-shaped feature, informally called Tombaugh Regio after Pluto's discoverer, includes a smooth, unmarked plain of nitrogen ice showing no visible impact craters at all. A strong indication that the surface there is geologically young, actively resurfaced by some ongoing process, rather than ancient and static as many scientists had expected for such a small, distant, cold world. New Horizons also detected mountains made of water ice, some reaching several kilometers high, and found evidence suggesting cryovolcanism, ice volcanoes that may erupt slushy mixtures of water, ammonia, and other compounds instead of molten rock, a phenomenon also suspected on several icy moons elsewhere in the outer solar system. Pluto's largest moon, Charon, turned out to be similarly fascinating. Roughly half Pluto's diameter, large enough that the two bodies technically orbit a shared point of gravity located between them, rather than Charon simply orbiting Pluto the way our moon orbits Earth. New Horizons revealed Charon's own surprisingly complex surface, including a mysterious dark reddish region at its pole that scientists believe may form from gases escaping Pluto's thin atmosphere, drifting to Charon and undergoing chemical reactions there. Pluto's thin, wispy atmosphere, composed primarily of nitrogen with traces of methane, turned out to be far more dynamic than expected too. New Horizons detected layers of atmospheric haze extending high above the surface, and found evidence the atmosphere may be slowly escaping into space, streaming away from Pluto over time. Taken together, New Horizons findings reshaped how planetary scientists think about small, icy, distant worlds generally. Pluto is not simply a dead ball of ancient ice, but a genuinely active, geologically complex body, still shaping its own surface through processes not yet fully understood. Despite sunlight there being roughly 1,000 times fainter than on Earth and surface temperatures hovering hundreds of degrees below freezing. Whether or not Pluto counts formally as a planet remains an active debate among astronomers, and reasonable scientists genuinely disagree about which definition best serves the science. But New Horizons settled a different, arguably more interesting question decisively. Whatever we choose to call it, Pluto is a far stranger, more dynamic, and more scientifically rewarding world than its former status as the smallest, most boring planet ever gave it credit for. 76 years after its discovery, and mere years after its demotion, humanity finally saw Pluto up close for the first time, and found a heart-shaped glacier, ice volcanoes, and an escaping atmosphere waiting at the edge of the solar system, regardless of what label we decided to put on it. If this story moved you, subscribe to Cosmic Horizons. The universe is full of stories like this one, and we tell a new one every day.